We're going to talk a little bit about system commissioning, so I'm going to make it quick and we're just going to run through it because sometimes we talk about these in fragmented ways and then you don't put it all together, but every time you're doing a new system setup or you're doing a major component replacement, you have to do a full system commissioning. So let's say you replace an evaporator coil, you replace a compressor. Recently we did a TXV. You install a new blower motor. You do anything that's really critical to the system's operation, you need to do a full system commissioning, which is different than, say, if you cleaned a drain line or if you did a maintenance or if you changed a capacitor or a thermostat. Now you have to test everything that's pertinent to that repair, but you're not necessarily going to go through soup to nuts and make sure that the system is fully commissioned. Mostly it's any time that you interact with, we're going to talk about this, anytime you interact with the airflow of the system or you interact with the charge of the system. So the refrigerant in the system or the airflow in the system. So we're going to talk about the ABCs. A, B, C's. And there's two different ways that people will talk about the ABCs. So A is always airflow, C is always charging, but some people will say airflow balancing and some will say airflow before. So either way, if you're wanting to be really thorough when you set up a new house or a new system, your ABC should be set your system airflow, then set your air balancing to make sure that you're putting the air in the right places, and then do your charging. That's the proper way to commission a piece of equipment. Or if you're working in a combustion heavy environment, sometimes instead of saying charging, they'll say combustion. So your airflow balancing combustion. And so maybe if you want to, you could put combustion down here. So there's actually more like 5. It's handy because they all use the letters ABC. I'm going to also add in another one here, another C, condensate. Because in our market, that's a big one. But this embodies what system commissioning is all about, and it is in this general order. If it's ABC, so airflow before charging, and then also add in combustion and condensate if you want, are we really checking airflow first? Are we thinking about airflow first? That's the question. So airflow, what is the first way that you confirm airflow when you're working on a system? What's the first way? No, really, like what's really the first way you confirm airflow when you're working on a system? And so there's two different airflows. The one that you're going to focus on when you think of airflow is the blower motor, right? So if it's not running, then obviously you can't check the rest of the system. You just can't. But there's another airflow, condenser fan, right? So your condenser fan's your other airflow. So you have to have both of those airflows. They both have to exist first. So you make sure they exist by just listening, right? And that's actually a step I never want you to skip. You're doing a service call, you're doing a system setup, I never want you to skip the step of just confirming that, hey, blower's running, condenser's running. And not even just blower's running, but blower's running and it sounds normal. You know, it sounds like a blower that's running up to full speed. Or it doesn't sound like, woo, you know, like it's sucking air in from every hole in the cabinet. Because that happens when you have airflow restrictions, especially with variable speed motors where they're trying to draw air and you've got a dirty filter or you've got some sort of airflow restriction, right? So if you listen to enough of them, you notice those things. So you don't skip that step. Condenser fan's got to be running. I always throw my hand over the top. Why? Why do you throw your hand over the top of the condenser? So what are you feeling when you throw your hand over the top? You're feeling the heat that's being rejected from the inside of the house, right? But here's another thing. What happens if I throw my hand over it, I see the motor running, I throw my hand over it, and I don't feel any air? Well, it could be running backwards. Could be running backwards. If I throw my hand over that condenser fan, and I hear it running, but I don't feel any air, I'm going to look down, okay, is that blade spinning? Yes. Could be running backwards. It happens. Good technicians listen and feel before they start doing measurements, before they start taking measurements. There's nothing worse than a technician who knows the measurements to take, but they miss the obvious things that lead up to before you even take that measurement. Like, why would you check your refrigerant charge if your condenser fan motor was running backwards, or your blower motor wasn't running, or your blower motor was running so slow that it hardly mattered because it wasn't getting the proper calls, like we've talked about, or your filter's so dirty that it's barely getting any air through it? Those are all pointless tests. So you always do your visual and auditory inspections to confirm your system airflows before you do anything else. And so installers, I'm not just saying this, like this is legitimate. This is what I want you to do. You start a unit up, start up the blower first, listen, is it running? Does it sound like it's coming up to speed? Is it set on high speed? Great. Now you go to the condenser, you put in that disconnect, you're listening. Compressor running, condenser fan putting heat out the top. Don't start focusing on your gauges right away. Now you do want to watch to make sure your suction gauge doesn't dive down to 0 or something. But what you don't do is like what we talked about the other day, where you start jack and charging it before it's stabilized. So now, once you've made sure everything sounds okay, you've got your airflows, now you let it run a little while. Because it's going to be tough to test a system until it's run 15 to 20 minutes. 30 is even better. You can clean up, you can start doing paperwork, whatever. whatever else you've got to do, but you want to let that thing run before you start doing testing. But even then, I want you to start with airflow, because it goes in this order. Airflow before charging. How do you check airflow? How do we check airflow? Often through static pressure, okay? But static pressure is like blood pressure. Here's the little thing I'm going to give you that I want you to take away when you talk about this amongst each other, and I know you do, because you just love talking about air conditioning with each other. That's, I just know that. So I appreciate that about you. Static pressure is like blood pressure. Does blood pressure tell you how much blood is flowing through your body? No, it doesn't. Blood pressure is just the pressure of your blood against the walls. Okay, so static pressure is not a measurement of airflow. We are not measuring airflow when we measure static pressure. When we use static pressure as an indicator of airflow, we're making some assumptions. And one of the primary assumptions that we're making is that the blower is moving the amount of airflow that it's supposed to move, or that the blower is at least spinning up to the RPM that it's supposed to spin to. So, and that the blower is the right size, all that sort of stuff, right? So, in order for us to trust static pressure, we should have some idea of our CFM target, right? In Florida, how many CFM per ton are we looking for? 350. 350 CFM per ton is what we're looking for in our market because of the high latent loads, high humidity loads. We run slightly lower airflows than the rest of the country because it sucks more moisture out of the air, pulls more moisture out of the air, colder evaporator coil. That's what we're looking to accomplish, 350 CFM per ton. 4-ton system, 1400 CFM, that's what we should be producing. So that blower has to be, I'm going to use the word trying, which isn't a good word for it, but it's a way for us to think about it. That blower should be trying to produce 1400 CFM before I can check my static pressure. Because let's say that you set up the blower board on an ECM, variable speed blower, and you set it up to a 3-ton instead of a 4-ton. So now what is that unit going to try to produce in CFM? 350 times 3 is 1050, right? All right, so it's going to try to produce 1050. So now if it's producing 1050 and I check my static pressure might look good. It might look low. And I'm going to say, oh, great, this unit's working great, right? But it's not working great because it's not moving the amount of air it's supposed to move in the first place, right? Your blood pressure will be very low if your heart is not pumping. Think of it that way. If your heart is not pumping, your blood pressure will be very low. It's the same thing is true of your duct system. If your blower is not moving a lot of air, your static pressure will be very low. Static pressure is like blood pressure, right? You get the correlation here? And so you've got to have that blower running up to the speed it's supposed to run before your static pressure can be trusted, because static pressure is not a measurement of airflow. Does that make sense? And so on new equipment, it's much easier, because on new equipment, you've got a brand spanking new piece of equipment. You've got a nice fancy chart that you can reference right away if you want, right there on your phone, because it's Carrier. You got the Carrier app. You can reference that chart if you want. It's pretty much always going to be, if you set it up properly, it's going to be 350 per ton, so you really don't even have to do anything more complicated than that. It says right on the data tag what your target static pressure is, which, what is it? Total external static target for the units we install is 0.5. Man, we've made progress. So you don't really have to do a lot of thinking. All you've got to do is set it up right? Then hit that 0.5 target as close as you can. And know that for every bit that you go over that 0.5, you're taking a hit. Depending on the type of motor, it's going to change. Sometimes you'll take a hit in airflow, but at the very minimum, you're going to take a hit as far as capacity and efficiency. Not always capacity, but always efficiency. You have higher static pressure, that blower is going to have to draw more amperage in order to do the same work, and it's going to result in it putting off more heat, and it's going to result in it using more energy. So the customer doesn't get what they pay for. Here's the point. Customer doesn't get what they pay for when the static pressure is over 0.5. They just don't. Now, sometimes it can't be helped. You got ductwork in between floors, you got all that, but in the sales process, what should we do? What should we do if we go to a house that we know we're going to install this new unit and it's going to be over 0.5? So we should always quote a job so that we can hit that 0.5 target. If we quoted a job and we cannot hit that 0.5 target, and we install it and we don't hit that 0.5 target, then we made a mistake in the sales process. Because at the very least, if we can't hit it, then what we need to tell the customer is, it doesn't look like we're going to hit our 0.5 target. Now, we can rip out ceilings and floors and redo all this ductwork and make a big mess in your house. Probably not going to be practical. But I just want you to know that your duct system isn't perfect for the size system that needs to go in here. And so you just need to be aware of that. Would you like us to pursue some options to increase airflow, even if it does require significant construction? No, I wouldn't like that. Okay, great. And you put that in the proposal. When it's 0.7, 0.75, 0.8, it's no problem. And you can know whether or not it's going to be a problem beforehand. The easiest way is to check static pressure while you're there in the sales process. And then kind of, if you want to get real fancy, you can use the fan charts and compare it to what the new system will be and all that. But you get good enough where you get really, you are able to look at the ductwork, you're able to look at what's connected to it, you're able to look at the existing system static pressure, and you can tell whether or not it's going to be a problem or not. But it takes paying attention, right? So, and I'm not going to go into all those specifics. Now we're talking about duct design. But do you get the point here? On an install, we have a blower that's supposed to produce a certain amount of CFM. You've got to set it up so it produces that, right? Again, airflow before charging. Then you've got to check your static pressure. Do those two things first. Do those two things while the system is ramping up, maybe 10 minutes into its running. Again, you want the coil to be wet before you start checking static pressure and things because that will affect it. You don't want to do it on a dry coil. But do that first. Confirm your airflow. Make sure your airflows are right. Condenser fan's putting air out the top. Bushes are trimmed back away from it. It's not too close to the wall. I've seen a couple recently that look a little too close to the wall, so pay attention to that. It's in the installation instructions. We've talked about that. So think about that when you're installing units, but just give your proper clearances. Then the inside, is it running? Does it sound right? Is the board set up right on it? And then check your static pressure. Even better than that, if you ever have a concern, you're checking a system and it's like, hey, my suction pressure's low, my superheat is low. We're going to talk about that in a second. That's when if you still think you might have an airflow problem and you know it's set up right, and you know the thermostat is set up right, and you know you're getting the proper calls on the board, which is G, DH, Y/Y2, all those things, the things we've been talking about in class for weeks and weeks and weeks prior to my surgery. Then you can have Max bring out the true flow grid, and we can confirm the exact amount of airflow moving through that system. But that's airflow. Confirm that first. Then we move into balancing, and this is true anytime we're doing any ductwork. And I want to talk about this real quick because I've seen this come up a few times, and I just want to make sure I'm really clear with everybody. Anytime we do any ductwork, any duct changes, we test before and we test after, and that requires the use of an airflow hood. We have several airflow hoods at Kalos. We have the couple little of the little CPS guys. We got a couple of the bigger ones, right? Anytime you're changing ductwork, we have to test before and we have to test after. We just have to. So just that comes from me. That's just how it has to be. We've already had the conversations. Jesse's on board with it. You got to test in and test out. The reason being is that when we test in and test out, now we can tell the customer that they have X amount of more airflow than they used to have. Now, sometimes that can't be done the same day because you're getting busy and things are going wrong, and oops, I don't have the hood, and oops, whatever, that stuff happens, especially on the test inside. But on the test inside, that should be done as part of the sales process, if at all possible. And if it isn't done as part of the sales process, then it needs to be, the salesperson needs to make sure that it's done as part of the installation process. Even if they've got to set up for a service tech to run by, or they've got to run by, or whatever. But test in, test out with duct changes. Airflow is also tied to balancing. If you set up a system airflow, and then afterwards you go in and you make all kinds of changes to it, you damper this down, damper that down, whatever, it can change system airflow, which can then affect your charging. So I don't want you separating out airflow and balancing from that commissioning because it's going to have effects. If you check a 0.5 static and then you go in and close down a bunch of dampers, well, now your static could be 0.6 or 0.65 or whatever. And so you have to make the balancing as part of this airflow test when we're making ductwork changes. And I know it's annoying, but it's less annoying than having to keep going back with a cranky customer. Because now you can have a very educated conversation and you can say, well, you did have 150 CFM in this room, and when we were done retesting, you had 175. Well, I'm still not comfortable. Okay, we'll see if we can get it up near 190, 200, but that's really the most that we can give it without stealing from other areas. It gives you a conversation that you can have with the customer. And all that's very logical conversation. It doesn't have to be super, sometimes we get so wrapped up in being so sciencey, like, well, we're gonna have to do a whole manual D and all this sort of stuff. A lot of this is very practical and it suits the way the customer lives in the house. A manual D, which gives you how many CFM each room should get, is based on a model. And people aren't models. They're, some customers are models, but that's a different topic. Especially not in the villages. They're not models, all right? And so people live in their houses in a very particular way, and so we can cater to that. Somebody has a room that's a bedroom, but they're using it as an office, or they're using it as a home theater, and it's got more heat in it. We can move some air around, but air we move here is coming from somewhere else, right? And so balancing is a science, but it is also an art. There is an element of it that is an art because you're tailoring to that customer's needs. And that's where having some measurements makes that much better than not having measurements. Because now they'll say, oh, I don't feel any more air. You can say, well, we did the measurement. Now, so you're not telling them they're wrong. You're just saying, well, we did the measurement before and you had 150 and now you have 175. It is an improvement, but it sounds to me like you would like a little bit more. Now, just keep in mind that when I give this room more, I do have to take it from some other places in order to do that. It's an easy conversation, straightforward. When we buy expensive tools to do a particular job, the answer is not the tool doesn't work, I can't do it. 0% of the time is that the answer. So balancing just means, at Kalos, when you're doing retrofits, it means somebody does a design, you test in, you test out, we make the adjustments, you use balancing dampers where you need to in order to get it where it needs to be. That's all balancing is. It's a little time consuming, but that's if we're charging a customer for ductwork, then we need to take responsibility for balancing. Anytime we do any ductwork, we need to take responsibility for balancing. Otherwise, the customer just calls us back cranky. That's just how it works, right? We do ductwork, we're taking responsibility for balancing. And I'm okay with us doing ductwork. The only thing with us doing ductwork, though, is we got to give ourselves the time to do it. So you have to think about that when we're loading up a schedule. If we got ductwork, we may not be able to get it all done the same day sometimes. Sometimes it's going to take a return trip, and that's okay. It's got to be that way. That's what it takes, because again, our goal is happy customers and good results, exceeding expectations. And so in order for us to do that, we've got to give ourselves the space and time. And when I'm having these conversations, I'm not saying that you're wrong, you're stupid, you're insufficient, none of that stuff, because I've gone through this same spectrum, and I'm expecting you guys to take everything that I've learned over 20 years and practice it now. And I understand that is somewhat unrealistic at times. However, just because I know that you're not always practicing these things perfectly doesn't mean that that's still not the standard. That's where we've got to get to. And you get there incrementally, but you get there by not making excuses for making those mistakes. So when you have a job and you get done with it, even a super happy customer, it just felt like the smoothest job in the world. There is still opportunities for you to have done better on that job. And a lot of it is about the conversations that you have right up front. So when you have a job that you know this unit's not going to hit 0.5, you need to have been having conversations about ductwork all along. James Russo is a great example of this, where we did I gave and I didn't personally handle it, which I could have, and that probably would have helped. But other than me personally handling it, I gave as much feedback as I possibly could, like, let's get this right, but still at the end of the day, we were over 0.5. Now, that's not to say he's not happy, because he is. It's not to say the job didn't go well in the end of the day, because it did. It's not to say it wasn't profitable, because it was. It's just to say that we could have done better. And the way we would have done better in that job was to say to James, you need some duct upgrades. Some duct upgrades would let you hit 0.5. Well, the price is already high. That's fine. You don't have to do them if you don't want to. We can do them later if you want. But just know our target is 0.5, and these systems aren't going to get there with the ductwork that you have. And I know the thinking, well, yeah, but the trunk is too small, and then the branches are too small, and everything. What are we going to do, replace the whole duct system? Sure, if that's what it needs. Now, you're not going to push it on the same day as everything else. That's not going to be practical. Just say, hey, normally this duct job would be $3,500, but we really can't do it in the summer. It's just too hot. Our schedule's too busy. But we can go ahead and do the system. It'll work fine. We can replace the ductwork come, between November and December, and we'll drop the price to $2,800. How's that sound? Well, I'd rather hold off. Fine. No problem. Because see, now he's the one who said I'd rather hold off, not us. Not us failing to tell him. Do you guys understand what I'm saying here? And the same thing is true when you show up as an installer on a job that you know there's going to be a problem. You know this air handler's not going to fit. You know this ductwork is too small. Stop the presses, talk to your manager. Let's get it dealt with before you start unboxing anything. It's going to make life so much easier. Now again, you don't want to be a drama queen about it. It doesn't have to be all dramatic. The goal is to catch it up front. The goal is the sooner we catch it, the better. So you start in the sales process. You start when the technician first looks at it. That's better. But every way along the way, every time there's a pause and a new person looks at it, we want to keep having those conversations. And the biggest source of social pressure that's going to help make this happen is the conversations that you have with one another. Not dramatic conversations, not angry conversations, but clear conversations. This air handler does not fit. Oh, sure it does. You just dropped the platform. Stop and listen to me. This air handler does not fit. This is not the right thing to have been quoted. That's how you should talk to each other. Seriously. I'm not joking. That is how you should talk to each other. Not angry, not calling names, not saying you're a stupid idiot, whatever, but just clear. Because as it relates to airflow and balancing, it's huge. I mean, it is huge that the equipment fits, that the ductwork's the right size, and that we have the time to do the jobs that we're set to do. So again, I'm not pointing fingers at anybody, because I think you are all doing excellent jobs. It may sound like we're picking on Tyler a little bit. Tyler has sold a tremendous, no, I want to be clear. I mean, like, let's not pretend, right? Tyler has sold a tremendous amount of equipment, and he's had to learn how to do all of this in a very short period of time after Sean left. So I think he's done a great job in that regard. But we just have to get better up front, that's all. No big deal. But you guys get the ABCs. This is what I want to get to. Now, you get to charging. I want to be really clear about charging, because I think sometimes I have given mixed signals. For installers, weigh. I've mentioned this in recent classes, but weighing in the charge is number one. And that does not mean that you don't check superheat, subcool, split, and saturation, but it does mean that you weigh first. And so if it's a flush application, you are smart young pups. You can guess pretty darn close how long that line set is. All right? If you ran the line set, well, then you pretty much know exactly how long the line set is. And every unit is going to tell you, based on how long the line set is, how much additional charge you have to add. Or you don't have to add any, right? Depending on the length. So you weigh it in. I don't care if it's ductless. I don't care if it's a split system. I don't care if it's a package unit. I don't care if it's a window unit. I don't care what it is. You weigh in the charge, which means that when you pull a tank off your truck, what do you pull out with the tank? Scale. And what does your scale need to have in it in order to work properly if it's digital? It needs to have batteries in it, which means you're going to have batteries on your truck. I know this is complicated, but you got to have batteries. Now, hey, let's say you're really bad with batteries. Keep a backup. Keep a analog scale, whatever, something, just so that whatever you need to do in order to support yourself so that you're not out of tools to do your job, then do that. So you're going to weigh it in. Once you weigh it in, how long are you going to run it? 20 minutes really is ideal. If you're doing a service call, okay, you're just adding a little bit, you maybe not run as long, but a brand new unit, you got to let it run a while. Then you're going to check superheat, subcool, air temperature split, which is one I think we're not doing as much as we should. Return temperature, supply temperature, check that regularly, because that does tell you a decent amount about airflow especially. Split, subcool, superheat, and then saturation. And saturation is just what is my liquid saturated temperature, so the temperature on the gauge, otherwise known as condensing temperature, and what is my evaporator or suction saturation. Now, I would love it if you guys would change your language and call your suction saturation, what you see on the gauge, call that your evaporator temperature. Now, some people, again, I've talked about this recently, some people will argue, well, that's not exactly your evaporator temperature because the surface is, forget it. Call it your evaporator temperature, and call your liquid temperature, not your liquid line physical temperature, I'm saying the one that shows up on the gauge, the temperature, call that your condensing temperature. You guys follow what I'm saying? So the needle's pointing at that temperature, or your testos are showing you a temperature, and I think testo will even say EV or CO or something like that. Call it that, because it makes it more clear what you're talking about. Because when you say my evaporator temperature is blah, that's much more clear to you, because now you can envision your evaporator being that temperature. And that's pretty darn close to what your evaporator temperature is going to be. When you say condensing temperature, you can imagine your condenser is that temperature. And now that makes it easier for you to do what I've shown you in the 5 pillars, which is compare those two temperatures to indoor and outdoor temperatures in order to anticipate what your pressures ought to be. And then check your superheat and subcool. Most of the systems we work on nowadays, if not darn all of them, on installs are TXVs, which means that subcool is our primary checking indicator. But it is not our only indicator. Weigh, subcool, superheat, split, saturation. Those are the things we're looking at. We're going to throw in the electrical side. You're going to check amperage, right? On an install, it doesn't mean much. How many times have you stopped the process like, whoa, my amperage isn't right? Not very often. In fact, if I couldn't get you to do both electrical measurements, I would rather you check voltage than amperage of the two. You need to check both. But I know right now, if I were to go watch most of you, you're not checking voltage. But checking voltage is actually more valuable, because when you check the voltage while it's running, going into that contactor, what is that telling you? The voltage. It's telling you the voltage. Under load. So it's going to tell you if you have problems with your circuit. If you have issues with connections and all that, you're going to have voltage drops. It's going to tell you, am I applying the proper voltage to that unit? What's cool is that unit tells you what the acceptable voltage range is right on it. So you can note, am I giving it the right voltage? This is especially important when you're doing light commercial stuff, 208 volts. Sometimes it's going to be low, and that's a big problem. All right, so that's something to look for. Sometimes it's going to be high. We know this because we've installed a lot of these ICM 493s and we find out that they're going off because of high voltage, and that's something we got to deal with. So amperage and voltage, and then finally, if you're doing a gas furnace, we got to think about combustion, which starts with checking gas pressure, and then you go into the combustion analysis, which again, policy is we do a gas furnace, we're doing a commissioning afterwards. Airflow, gas pressure, combustion. And I want you to all know how to do that eventually, but that's a slow thing, so mostly Max is going to do that for now. And then condensate. Condensate means primarily two things. Is it draining? Now there's a lot of things that go into making it drain, but is it draining? And does the float switch work? So you have to test the float switch to make sure the float switch shuts it off, and you got to make sure it's draining. That, my friends, is a commissioning. That's how you commission a system. Airflow, balancing, charging, combustion, condensate. ABC. But it starts with airflow. Starts with visual and auditory analysis of your airflow, moving into confirming that it's set up properly, moving into your static pressure checks. There's a lot of people who will say you should be actually checking airflow on every system. And then the next question is, well, how do you do it? You do it with an airflow hood at every distribution point, at every return. How do you do it, right? Checking airflow is tough. So we use static pressure as our method, just knowing that in order for static pressure to work, a lot of other things have to be correct first, which is why static pressure is really tough as soon as that blower wheel gets dirty. Because if that blower wheel gets dirty, it's like your heart not pumping enough blood. If your heart's not pumping, you don't have high blood pressure, right? It's a whole nother problem. A guy with a really high blood pressure, his face is all bright red and everything, and he's got really high blood pressure, his heart's pumping, but his circulatory system is all clogged up, right? Or he's got issues with the circulatory system. Now, there's other things that go into this. Again, this is why we talk about, in order to know how to commission a particular piece of equipment appropriately, what do you need to do? Read the manual, right? You have to read the manual because not every piece of equipment is the same. You know, you have a system that's got a belt-driven pulley, or it's, you know, got greasable bearings, or it's got, you know, there's all these things that you got to look at on various pieces of equipment. So really, in order to know a piece of equipment, you got to read the manual. Or you have to have worked on it enough to make enough mistakes to know everything there is to know. And with as much different types of equipment as we work on, that's not generally practical. If you were to walk up to, so Carrie, let's say you walk up to a Train 19i with a communicating system, and you have some weird problem with it that you've never seen before. The very first thing you should do is just read the manual. Now, the customer's going to say, well, what are you reading the manual for? If they happen to see you. And here's the answer to that question. The answer to that question is, I've worked on a lot of systems, but anytime, you know, you have a very special system here, and I just want to make sure to go through all the checklists to make sure I don't miss anything. Again, when a customer questions you on timeliness, all you do is mention thoroughness. If they question you on timeliness, you just mention thoroughness. All right, any questions about this? So this is commissioning. This is what commissioning, so when I say commissioning, this is what I mean. So if I say, did you commission the system properly, this is what I'm talking about. If you wired her up and fired her up, that's not commissioning. I just came up with that. I kind of like how that feels. Wired her up and fired her up. I'm sure I heard it from somebody else before. Yeah, so that's not how you do it, right? You wire up and fire her up, and then you commission. Oh, I want to address real quick, because I've heard a couple people say, I've heard this in passing. I've heard some people say you can use a recovery machine in place of a vacuum pump. Can you do that?
Yeah.
No, absolutely not. It will not work. I've heard some people say that if your vacuum pump's not working, you still got to get the job done. Is that true?
Negative 20 psi.
Yeah. If your vacuum pump's not working, do you still just blow and go, get the job done, get her done? You got no choice? Send it? No, you don't. You get a vacuum pump. I don't care. If we've got to go back the next day, I don't care. If you've got to wake me up in the middle of the night and I'll open up the office to get you a vacuum pump, that's what we do, if that's the only option. You understand me? We get a vacuum pump. That's how that works. You keep clean vacuum pump oil in your pump, that's going to make your pump last a lot longer. When I see pumps that fail after 2 years, pretty much 100% chance it's either been tumbling around in a truck like a gymnast, or it hasn't had the vacuum pump oil changed in it regularly, or it was crazy overfilled or something else super stupid. They don't fail if they're maintained properly. They last for freaking ever. So you just take care of them, all right? So we have really nice tools that we, you know, vacuum pumps, recovery machines, all that kind of stuff, nice tools. But you have to take care of them. If you don't know how to take care of them, you're like, well, I don't know how to put the oil in this. What do? You read the manual. Do you know what I do? I read the manual. That's what I do, right? It's not magic. I did, see? You guys are paying attention. Yeah. All right, so you use a vacuum pump. Vacuum has to be pulled down to a very deep vacuum, to the micron level, for it to do any good. If you don't pull it down below the boiling point of water, you are essentially doing nothing. And so using a recovery machine is not doing anything. It's pointless. You might as well not even do anything. So you have to use a vacuum pump. You have to use a micron gauge. Have we sufficiently proven at this point that removing cores using big hoses is like magic and it works amazing? I think we've proven that at this point. Use your large gauge hoses, pull out your cores, do vacuum appropriately, and it's actually not a huge deal. It just requires a process. It requires being a thinker. All right? We're a premium company. Our goal is, as Jesse's going to hammer quite often coming up, our goal is to have technical excellence, to be better than anybody else in this marketplace, and to give people good experiences when they work with us. That means us having good experiences working with each other, not fussing, fuming, and fighting, not having issues with each other, and our customers feeling really great about the interactions that they had, where it was just pleasant. It was just nice working with us, right? Those are our two goals. Low stress, technical excellence. Having a good time, enjoying each other's company, being technically excellent. If you do those two things, nobody's going to have any problems. And on the other hand, for those of you who aren't technicians, I would say everybody is a technician. If you're an installer, you're a second, you're an install technician. A technician has a technician mindset, which is, I'm getting this job done, I'm doing it right, it doesn't matter. Doesn't matter what happens, doesn't matter what I run into, I'm going to stick with it until I get it right. Sometimes that means we got to come back the next day. Sometimes that means we can't get it done tonight, okay? That's what it means sometimes. Now, I'm not saying that you just, 5 o'clock is beer 30, I'm taking off. That's not what I'm saying, but I'm saying that you stick with it. You don't give up. You don't bail on a job. And what happens in a lot of cases is, it's 9 o'clock and I'm not even close to being done. So now we just, and that's not how we're going to do it moving forward. We're not going to do, you like that sound? We're not going to do that. That's the brain fart, just giving up on the job. Technical excellence requires sticking with it until it's done correctly and not getting dramatic about it with each other, just sticking with it and communicating clearly. Look, it's 9. I've got 3 hours more work. I think it's better that we bite the bullet and talk to the customer now and just tell them we'll be back in the morning to finish off. Well, we've got 4 changeouts tomorrow. Okay, what do you suggest? We'll figure out something. No, we will. We will. And that's what's cool about Kalos is we will figure out something. And the reason is because everybody is willing to hop in a truck and help out. I need to be willing to hop in a truck and help out when I'm needed. Jesse has proven that he's willing to hop in a truck and help out when he's needed. Les, Nathan, everybody here. Dan, I think Dad might be an exception. I don't know that you would want him. You probably wouldn't want me either, but I'd still do it for the moral support or immoral support, as the case may be. But that's what Kalos is built on. Technical excellence and just having a good time, doing what we do, and doing it in a way that people feel good about the interaction that they had with you, right? Cool. Thank you guys. Have a wonderful day.